methods such as substitution and elimination help solve systems of equations because you cannot solve for, more than one variable in one equation. Okay, so if I have an equation with x's and y's, like example 1, if I just have x plus 2y equals 4, I can't solve that because there's two unknowns. I need as many equations as I have variables. So if I have two variables, I need two equations. And there we go. All right, so our goal is to first solve an equation one equation with one variable in it. Okay, and the first method that we're going to revisit is substitution. And substitution, to use that method, you want to isolate one variable in one equation. Okay? And that one variable that you're isolating is kind of like the sick teacher who needs a sub, right? So you can look at your two equations, and we're going to pick which variable is easiest to isolate. Yeah, x in the first equation, right? Because there's no coefficient. Okay, so I'm going to choose to get x by itself in this first equation. So all we would need to do is subtract 2y, right? So now I have x equals 4 minus 2y. Or negative 2y plus 4, doesn't matter. Okay? So when a teacher is sick, the sub comes and takes their place, right? So x is like your sick teacher. This is the substitute. This is the sub. And it's going to go take the place of our sick teacher, x, in the other equation. So I'm going to go to the other equation, and I'm going to plug in the substitute for x. Okay? You always go to your other equation and you plug that in. Okay? So now I'm going to say, all right, this is 3 times x, but I'm not using x, I'm using the sub, right? Minus 4y equals 7, and then the sub is going in for x. And the sub is 4 minus 2y. So it's so important that whenever you substitute, you put the substitute in parentheses. Sometimes it doesn't matter, but most of the time it does, so you always do it, okay? All right, now I have one equation, and how many different variables are in this one equation? 1, so we can solve it, okay? Because I only have y's. So we use all of our algebra skills to solve, so we're going to distribute the 3 into the parentheses. So we have 12 minus 6y minus 4y equals 7. And then we combine our like terms, right? So I have 12 minus 10y equals 7. Now we get y by itself, so we subtract 12. So we have negative 10y equals negative 5. And then we divide by negative 10. And negative 5 divided by negative 10 is going to be a positive 1/2. Right? Okay, so we have y, but remember what we're doing. We're solving a system. These are lines. We're not graphing them, but they are lines. So we're trying to find the point where they meet. So we not only do we need y, but we need x. So now we substitute again, right? We're going to take our y and we're going to plug it in to any original equation. I could use one of these that are printed on the page, but the easiest one is always going to be the one with your substitute in it. Okay? So now in this area I'm going to say, all right, I'm going to plug in y to find x. And I get to choose what equation I want to use for that, and I'm going to choose my substitute because I'm going to choose this one, x equals 4 minus 2y. So I'm going to use x minus 2y, and I know what y is. I know that it's 1/2, so I'm going to plug that in. So 2 times 1/2. Wait.
Minus 4.
Equals, sorry. Whoa, hold up. What did I just do? I didn't plug that in right. X equals 4 minus 2y. So 4 minus 2 times 1/2. There we go. Because I'm plugging it into this equation. X equals 4 minus 2y. And I'm just plugging in y. Okay, so 2 times 1/2 is 1, right? 2 halves make a whole. So x is 3. All right. Now, we got to write our answer, just like we did before. This is a coordinate point, so the solution goes in solution set, right? And the point, the x comma y, is 3 comma 1/2. That is our solution. Goes in a solution set. Okay? Y'all remember doing this? Typically, substitution wasn't everybody's favorite, but if you know how to use it, it can actually be pretty good. Okay, questions over this one before we try another one? All right, so now I'm being told to use substitution again with this system. And we got to figure out which variable, which equation to isolate. Doesn't always have to be x. It could be y. It could be whatever you want. But honestly, in this one, probably going to be x again, right? Would you pick x in the first equation or the second?
First.
Why would you choose the first over the second?
Number, even number.
Even number. Oh, okay. I see. And it's positive, right? I don't have to divide by a -1. So yeah, good eyes. But again, we can pick anything, right? All right, so I'm going to get x in this equation by itself. So just subtract 3y. So we're going to have x equals 18 minus 3y, or -3y plus 18. Does not matter. Okay, x, your isolated variable, that's your sig teacher. This is its sub. Okay, so we send the sub in to go in place of x in the other equation. So the sub is going to go take the place of the other equation's x. Okay? So now I'm going to rewrite the other equation. So I'm going to write 2y minus whatever x is. It's got a sub. It's not there. So I'm going to put the sub in, which is 18 minus 3y. This step right here is the key to the whole method. If we can do this, then the rest is just basic. Okay? Okay. Now, we've got to simplify, right? This is 2y minus this. So think of this as like a -1 being multiplied in. We're going to distribute the -1. Or distribute the negative is another way to say that. So I have 2y minus 18 plus 3y equals 7. And then we can solve from here, right? Combine our like terms. 5y minus 18 equals 7. Sounds like a card. But it might be something above. Okay. Plus 18 plus 18. 5y equals 25. Divide by 5. Y is 5. Okay, but now we need to get x, right? So I need to plug in. Plug in y to find x. And we get to choose what equation we use, but it's always going to be easiest to use your substitute equation. So I'm going to use that one. X equals 18 minus 3y, and y is 5. So x is 18 minus 15. So x is 3. And then I gotta write my answer in my solution set with x coming first, right? X comma y, 3, 5. Okay. So that's our substitution method. We use that when we have a variable isolated. Okay. The other method is always everybody's favorite. It's my favorite too, because anytime we get to eliminate things in math is a good day, okay? So the other method is elimination. Example 3, it says a recycled example 1. So this is the exact same system as number 1. So we know what the answer is. We know the answer is 3 1/2. But we're gonna take an entirely different route to get there. Okay? All right, so the deal with elimination, okay? The deal with elimination is you want to add equations together. I'm going to abbreviate equations with EQs. I'm going to add equations to eliminate one variable. And in other words, what we're trying to create is a zero pair. That's how things get eliminated in math, right? We make a zero pair. Okay, so if elimination is what you're doing, you're looking for which variable can you most easily make a zero pair. So right now, if I add these together, nothing is eliminated. But if I want to eliminate x, what would my zero pair need to be? 3 and negative 3. I could achieve that really easily, right? If I just multiply this first equation by negative 3. Okay? So that would be if I chose x. If I chose to eliminate y, what could I make the zero pair be there?
Times -2.
Yeah, I could turn that into 4 by multiplying by 2. So I have a positive 4y and a negative 4y already. Okay? So you start off with a choice, and then you can multiply equations by whatever you want to make that zero pair. So if I'm choosing to eliminate y, I always like to draw an arrow above the variable that I want to eliminate. That's the one that I'm targeting. Okay? I know that if I take this first equation and multiply it by 2, then that will create 4y, which is a zero pair with negative 4y, right? But the trick is, and here's where people mess up, you gotta multiply the whole equation. That's the rule, right? You can't do anything unless you do it to everything. So this will turn into 2x plus 4y equals, even that other side needs to be multiplied by 2, right? So equals 8. Okay? Now, I am not choosing to do anything with the second equation, so I'm just going to carry that over. 3x minus 4y equals 7. Because now what I'm going to do is I'm going to add these together. So I draw like an elementary school addition problem, right? Where you put the plus sign and the big long equal sign over there. Okay, so now I'm going to add these together. So 2x and 3x makes 5x. Positive 4y and negative 4y, that's my zero pair. So y is completely eliminated. Equals 8 and 7 is 15. And now look, I have one equation with one variable. So we can solve it, right? Just divide by 5, x is 3. Okay? But we need y. And this step is the same as substitution. We still need to plug this in. So I'm going to plug in x to find y. So I can choose any of the original equations. I could even choose the one that I multiplied by 2 if I really want to. So why don't we use probably the first equation? You want to use this one right here? All right, so I'm going to plug in x. So I know what x is. X is 3. So 3 plus 2y equals 4. So if I subtract 3, 2y is 1. And then divide by 2, y is 1/2. So now I have my x, I have my y, so I can solution set 3, 1/2. And we can check, all right, we did that one with substitution, and we got the same answer. Whoops, we got the same answer, but it was a whole different method that we used. Okay? So you can use both methods for either problem. So when do you have to use a specific method? If you're told to use a method, then you have to use that method. Okay? Otherwise, if it says just solve algebraically, you can pick whatever you want. All right. Let's do one where it's not so obvious how to make that zero pair. Okay? All right. If we choose x to eliminate, what would have to be the zero pair we would need to create? Anybody see it? 6. Positive and negative 6, right? Okay. If I choose y, then that zero pair would need to be what? 15. Doesn't matter what you choose. I like to choose with the smaller number because I'm not using a calculator. I'm just up here, right? So I'm going to choose to eliminate x. Okay? So that's the one that I'm going to target. I'm going to target x. So I need to create 6x and negative 6x. And it does not matter which one I choose to be positive or negative. Okay? Let's just say I want this one to be 6. So if I want this one to be 6, then I have to multiply the entire equation by what number? 2. Because that's what's going to make a positive 6x. So over here, I'm just going to multiply everything by 2. So 6x plus 10y equals negative 32. Okay, so if that one was positive 6x, then this one has to be negative. So this whole equation would get multiplied by negative 3, because that is what's going to create negative 6x. So negative 6x minus 9y equals, and a negative 3 times a negative 9 is a positive 27. All right, now we add these together. There's our zero pair, no more x, totally eliminated. 10y plus negative 9y is just 1y, right? Equals negative 32 plus 27. That should be negative 5, right? Yeah. Oh, look, we don't even have to do anything else. It's solved for us. Great. Now I need to plug in my negative 5 for y. So I need to plug in y to find x. All right, now I have 4 different equations I could choose from. I could choose the original, one of the originals, or one of the ones that I multiplied. But let's find the smaller numbers. Maybe this one? Okay. So 2x plus 3y, and y is negative 5, equals negative 9. So it's negative 15. So 2x minus 15 equals negative 9. So we can add 15 negative 9 and 15? 6. Divide by 2. What is x? 3. It's like all of these problems have the same numbers in them. Okay, so now I have to find a place to put my answer. My answer is the point 3, negative 5. Just make sure you're always putting x first. No matter what you solve for first, x goes first in the solution. Okay. Okay, there was like 1 week of Algebra 1 review. Okay, so what can I do to make it a little more Algebra 2? Well, you probably already saw this. You know what's coming. Fractions. Why not? Why not put fraction coefficients? You know how to deal with fractions. You know how to deal with fractions. How do you deal with fractions? You multiply by the denominator. You eliminate the fraction, right? Okay, so I'm going to write a little note. Before I even do elimination, I'm going to eliminate fractions first. And we know how to do that. Multiply by the denominator. Eliminate fractions first. Okay? Okay. So if I want to, just first equation, multiply by the denominator, right? So everything here gets multiplied by 3. Okay? I'm going to write that answer over here so I have more room. I'm just going to move this over here. So 3 times x is 3x. 3 times negative 4/3 y is just going to knock out the denominator, right? So it'll be minus 12y. Nope, just kidding. 4. Where am I getting 12? Nope, that's wrong. Sorry. Just knocks out the denominator. So it's minus 4y equals 3 times negative 9 is negative 27. Okay. We all okay with that? Now, what's going on in the second equation? I have 2 different denominators. Any ideas what we'd multiply there? 4, yeah. If you have multiple fractions, you're going to multiply by the common denominator. Okay? So common denominator of 2 and 4 is 4. So I'm going to multiply everything by 4. So when I do that, 4 times 1/2 x. 4 halves makes 2 wholes. 4 times, or think 4 times 1 divided by 2. Multiply, divide. So 2. So 2x plus 1y equals negative 7, because that will just knock out the denominator of 4 there. Okay, now you have no more fractions. Now this becomes a problem like the first one. All right, here's what I want you to do. I want you to take a couple minutes and go from here. Make a choice, your own personal decision, what you want to eliminate. Doesn't matter what you choose, right? Solve and see if you can get to the right answer, and we'll go over it so you can check yourself in about 3 minutes while I do my attendance, okay? All right, we'll do that right now. right, I'm gonna go over it with you. Raise your hand if you chose to eliminate x. Okay, raise your hand if you chose to eliminate y. Okay, you're all right. Everybody's right. I just want to do it the way most of you did it. So it looks like most of us chose to eliminate y, so that's how I'm gonna do mine. So I'm gonna eliminate y, which means my zero pair needs to be 4 and -4. I already have a -4. So all I really need to do, if I choose y, all I have to do is multiply the second equation by 4, right? So I'm going to bring over my first equation because I'm not changing that. 3x minus 4y is -27. And then I'm going to multiply this one all by 4. So that'll make 8x plus 4y. 4 times -7 is -28. Okay. All right, so now I can add together. 3x and 8x is 11x. Here's my zero pair. My y's are eliminated. And -27 plus -28 is -55. So now I divide by 11 to get x, and x is -5. Okay, now I gotta pick any equation. I'm probably not going to choose one of the original ones with fractions. I mean, we can, but we don't really need to. So I think I'm gonna choose this one to plug in, okay? So 2 times x, so 2 times -5, plus y equals -7. So -10 plus y equals -7. And if I add 10, so y equals -7 plus 10 is 3. So our solution, in our solution set, -5, 3. All right. Okay, raise your hand. Anybody get that one correct all by themselves?
Can you solve the other way of like getting rid of x?
I will, but I'm gonna do it after we do the cheeseburger problem, so that, yeah, the cheeseburger problem, the last one. But I will do it, but we should, it's just gonna be kind of backwards. You're gonna get y first and then x, but yes, I will, remind me, I will do this one the other way when we're done with the cheeseburger problem. Okay. You know that question about Ed Sheeran and Taylor Swift, and we were all like, wow, they only charge $15 for a VIP pass. AI made that problem. AI did not make this one, but I think in these crazy times, it's good to live, to imagine living in a world where this could be a possibility, right? 4 cheeseburgers and 2 chocolate shakes cost $7.90. Why not? 2 chocolate shakes cost 15 cents more than 1 cheeseburger. What is the cost of 1 cheeseburger and 1 chocolate shake? Okay, y'all have an RA, this unit, okay? And in this RA, it's a lot of this kind of stuff, word problems. And we have to define our variables if we are not told what variables to use. And we are not, right? Okay, but we find what they represent in the very end of the question. What is the cost of 1 cheeseburger? What is the cost of 1 chocolate shake? So let's decide on our first variable for cost of 1 cheeseburger. What do you want to use? What letter? C. Okay. So I'm going to say let C, because I'm not just going to like talk about C without communicating what it represents. Let C equal the cost of 1 cheeseburger. I'm not going to put let C equal cheeseburger. That doesn't make sense. C equals the cost or the price of, okay? And then I need one for the cost of a chocolate shake. What variable you want to use for that? S. Okay, let S equal the cost of 1 chocolate shake. or price of. Okay, now that we've defined our variables, what they mean, now I can write a system with them. Okay, so 4 cheeseburgers and 2 chocolate shakes cost $7.90. So that's talking about the money. So 4 cheeseburgers, so 4 times C, and 2 chocolate shakes, so plus 2S, cost $7.90. When I'm writing an equation, I do not include the dollar symbol. Okay, the dollar symbol is for my answer when I answer the question. Okay, now I go to the next sentence. 2 chocolate shakes cost 15 cents more than 1 cheeseburger. So 2 chocolate shakes, 2S equals 15 cents more than 1 cheeseburger. Well, 15 cents is 0.15 more, so plus 1 cheeseburger. We'll see. Bless you. Okay, now I have to go a step further than I did in the last unit. Now I'm actually going to solve this. But they're not telling me what method. So what method would you use? The answer to all that is, yeah, you're right. But what would you use? Elimination. Because you see like, oh, these match. We just have to move the C, would have to live over here, because for elimination they have to be stacked. Yep. It's pretty okay to do with elimination. Would anybody use substitution? Hold up. Yeah, y'all see it? Who sees it? Carla, what do you see?
You use the 2S in the English 56 plus C as for the substitution.
Yeah, I don't have to get S all the way by itself. 2S is that. Well, guess what? There's a 2S there too. All I have to do, honestly, I could do substitution. Let me pick a different color. Another color. 2S equals this, right? So there's 2S. I don't even need 1S because I have the exact same term. So why not do that? Let's see. Let's use that. So 4C plus, I don't even need 2S to get by itself. 2S is 0.15 plus C. I'll go ahead and put that in parentheses because I'm subbing. And that equals $7.90. Now, in this case, the parentheses don't really matter because I'm not distributing anything, right? There's like a 1 here. So I can just combine like terms. 4C plus another C is 5C. That's 790. Okay, so take out that 15 cents. Ooh, mental math. Okay, so 5C equals 790 minus 15 cents. 775. Divide by 5. Okay, mental math. $1 and 25. 55. Yes? $1.55? 1.55. Not that you can't pull out a calculator and easily do that math. I'm just not going to pull that out. Okay, cool. That's C, which is the cost of a cheeseburger. I also need the cost of a shake, right? So I need to plug C in to one of these equations. Okay?
2S.
Yeah, maybe this one, because it's just 1C. It's less work. So I'm gonna choose to plug into this equation. So 2S equals 0.15 plus C, which is 1.55. So 2S is going to equal, so 15 cents plus $1.55 is $1.70. 1.70. divide by 2. If 2 shakes cost $1.70, then 1 shake costs 85 cents. Whew. In what world? In what world is that the case? Okay, now, it does not make sense to put this in a solution set as an ordered pair, right? Because we're actually not talking about 2 lines on the coordinate plane. We're talking about burgers and shakes. So we got to go back to the question and answer appropriately. What is the cost of 1 cheeseburger? $1.55. What is the cost of 1 shake? 85 cents. So I have to write that. Now, where do I have room? That's the question. I'll put it out here. So 1 burger, I'm just going to abbreviate because I don't have a lot of space, costs $1.55. So now I bring my dollar sign out because I'm answering the question, right? And 1 shake costs 85 cents. With the dollar sign, $0, 0.85. Okay, that's how we communicate about money. Okay. All right, so look for that to be largely what your RA is going to be about. Okay. Okay.